Welcome to video 26 on fun with Arduino. In the previous video we connected a rotary encoder, but we did not yet really do anything useful with it besides sending a pulse width modulated signal to an LED. In this video we are going to connect a servo motor because with any application that you are going to do with the servo motor, you will at some point in time have to find the minimum and the maximum angle that you need to control that application, the mechanical part of it, in the proper way. So it is nice to use a rotary encoder to tune the servo for the minimum angle and then use the push button switch to go to the other angle and tune that angle also, and then read out those angles on the PC screen. That's what we are going to build, so let's have a look at the code. This is the code that we had in the previous video to read out the rotary encoder, and we are now going to add all the instructions we need to control a servo motor. And the first one is that we define the servo pin, the pin number where it is connected to. Then we define a speed, or actually the interval time in milliseconds between steps when we send out the angles to the servo motor. That makes up the speed, so lower numbers are higher speed. And I found out that 30 looks quite okay. And then there are different servo motors on the market. Some have 180 degrees and others go no further than 90 degrees. So we need to take care in our code that we never exceed the send out angles outside of this range. So we need to do a test further down the road to check if the set point stays between this minimum and maximum. Alright, let's go to our declarations. The new ones are here. I have now a set point, which is an array with two values. I use a 180 degree servo, so it seemed like a good idea to at startup to give it 80 degrees as minimum and 100 degrees as maximum. Small angles, so that we don't break anything mechanically if we send it to those points. Then there is a pointer that points to this array, so we are going to use that to change if we press the encoder button. And then we have an angle. The angle is going to move towards the set point, and at startup I give it this value, the midpoint between the minimum and the maximum allowed angle. So if you change these angles over here, then the midpoint is automatically calculated. No need to do anything in that part of the code. Let's move on. The next thing that we need to do is, of course, include the servo library, which is readily available in the Arduino install. And then we create a servo and we give it the name servo. Yeah, why not? It sounds crazy, but it's as simple as that. Then in setup, the only thing that we need to add over here is to attach the servo to the servo pin, which we do here in this statement. And then we are ready to use the servo. Well, in the loop we are going to read out the switch. And that code has not changed, but for this one line over here, if the encoder button is pressed, we change the pointer to the set point. And with this formula, the pointer becomes the pointer plus 1 modulo 2. It will be only 0 or 1. If it was 1 and we add 1, then it becomes 2, and then this modulo 2 takes care, it becomes 0 again. So the only valid numbers for the pointer are now 0 and 1. And once it has changed, it means that now our servo is going to rotate, because at startup it had the angle 80, and now we changed the pointer, so the angle is now, the set point is now 100 degrees. at least at startup. Let me go down to the end of the code where we start to rotate the servo. We do that, we check if it is time to do it, and if it is time, then we change our future time to move. And then these simple statements over here. If the angle is smaller than the set point pointer, and the pointer, we press the button, so we just changed it from 0 to 1. Set point 0 was 80 degrees at startup. Now it is set point 1, which is 100 degrees at startup. So we start to move because every time we increment the angle and we write that new angle. The other way around, if the angle is larger than the set point, then we decrement the angle, and then of course we write that new angle. So this is how the set point changes take care that the servo starts to rotate. Okay, this is what we did here in the switch, the push button switch. Let's now have a look what we are going to do when we read that the rotary encoder has been rotated. We did that over here, that code has not changed. But now what has changed? If we detected a low to high transition, we check the data, the B channel or the data channel as it is called, and at one point we increment the set point, or if the B channel was 0, then we decrement the set point. So our set point is now the value that we are going to change. And then we of course have to take care that our new set point stays within the range of the maximum and the minimum values, otherwise we could probably even damage our servo. I don't know what happens, I never tried it, but we better not experiment with it. So we have a new set point, but first we check if the new set point now is larger than my maximum angle, then I reset it to my maximum angle. So I will never get a value larger than 180. And also for the minimum angle, which I have set at 0, if my set point becomes smaller than that, we immediately change it to 0 or the minimum angle. So this takes care of never going out of range. Well, enough talking, let's put it to work and see if it really works. Let me upload the code and start a video so that we can see it to work. Yeah, ready. Open the serial monitor. That says that the tuner is ready and the current angle is 80 degrees. If I press the button, it should go to 100 degrees. Yeah, it does that. It moved, and it says here on the serial monitor it is now at 100. And let me rotate it now a little bit further. Yeah, I see on the serial monitor that the angles are changing, and I also see the servo is rotating. So now the whole job is to check with our mechanical construction if this is the right angle for situation 1. Then I press the button and we are going to the other angle. Set point is 80 right now, and I'm going to change it, and then we will see if the angle is what we need at a certain moment in time. Let's say, just for demonstration purposes, this is the right angle. I can read on my serial monitor that it is 37 degrees, so I press the button now and the servo is moving between 124 degrees and 37 degrees. And if I decide that these are the correct angles for the application that I have, be it a junction, a point that we switch on our layout, or a garage door, or a beam or a gate of a railway crossing, no matter what, it has the mechanics, and we have found the right angles, and now we can put these angles in our code. Okay, two things that I would like to improve. If I need to change an angle, but the increment right now is 1, yeah, then it can take quite some time, quite some rotation before I am 90 degrees further if I need it. So it would be nice if we can detect how fast I am rotating and then make larger increments if I'm rotating fast. So then I have a fast and slow increment. That could be, yeah, an improvement. Also, I would like to be able to see what the midpoint is. I can right now only switch between the minimum angle and the maximum angle, but suppose that I can make it such that when I do a long press, 1 second, 2 seconds, and then release the button, that then it goes to its 90-degree angle. So we need to have a little bit more timing in our code to detect a short and long press, or to detect a slow and fast rotation speed. Let's do that in the next video.